So while you're doing this warm-up problem, just remember that tomorrow there is a formative in the Resource Center, and Friday there is a quiz in class. So we got that. We got 2 formatives coming up to go, and then next week we got our chapter test on Wednesday, and then the following week we got our final. Good times. So, thinking back to things that we've talked about in this class, things that you talked about in Algebra 2, things that you talked about in Geometry, things that you talked about in Algebra 1, how would I go about solving 3x plus 4y equals 1 and x minus 10y equals 6? I want to solve that bad boy. How do I do it? The bottom equation by -3. And why did you do that? So you're using, do you remember what it's called? You're using elimination. Yep. Okay. So one way is we could multiply the bottom equation by -3, have the 2 equations together, solve for y, then put that back in and solve for x. Okay. What's another way that we could do it? Substitution. How would you do that one?
Since x is the revised solve on the second equation, put 10 on another side.
And then substitute in 10y plus 6 in place of x in the first equation? Love it. Love it. And then so then you would solve for y that way and then get what y is and then plug that back in and get what x is, and love it. Love it. Okay, that's 2 ways. What's another way? What's another way to solve this system of linear equations? And I'm guessing 0 people chose this way, but it is a way yet. Anybody remember? We could graph the 2 lines and see where they intersect. Where the 2 lines intersect, that's the solution of what x is and what y is. Okay? So I'm going to go with the elimination because that's the kind of way that I like the best. So I'm going to go with this equation times -3. If I multiply that equation times -3, I get 3x plus 4y equals 1. And I get -3x plus 30y equals -18. Add those 2 equations together. The 3 x's cancel each other out. Leaves me with 34y equals -17. Then I would divide both sides by 34, giving me y equals -1/2. Then I'm going to put y equals -1/2 back into one of the equations. And that gives me 3x minus 2 equals 1. Add 2 gives me 3x equals 3. Divide by 3 gives me x equals 1. So I get a possible solution here of 1, comma, -1/2. And just to make sure, what should I do? Plug them back into both equations, right? 3 times 1 is 3. 4 times -1/2 is -2. 3 plus -2 is 1. 1 is equal to 1. 1 is 1. -1/2 times -10 is +5. 1 plus +5 is 6. And 6 is equal to 6. So there is my solution. Okay? Good times good algebra. Too far on my page, too far on the page. There it is. Okay. So in previous classes and chapters, we solved linear equations one of three ways. We had graphing, we had elimination, and we had substitution. Okay. Right. We also could have done Cramer's rule, but we skipped over that because of snow days, and we could also solve by matrices, but we skipped over that because of snow days, and so we lost out on those two, but that's okay. I'm okay with that. Okay. Today, what we're going to do is we are going to solve a quadratic system. Okay? A quadratic system is a system that includes one or more conics. Okay? So we might have a conic and a line. We might have, like in the first one, then we got a circle and a line. We might have two parabolas. We might have a parabola and a line. We might have a parabola and an ellipse. We might have two hyperbolas. Okay? Who knows? Okay? We're going to have at least one conic section and then one possibly conic section. Maybe it's a line, maybe it's not. Okay? So again, it's going to help us to know what the conics are. You have these written down many, many places and many, many times. Okay? You know that a circle is x minus h quantity squared plus y minus k quantity squared equals r squared. You know that a parabola comes in one of two forms. Either x minus h quantity squared equals plus or minus 4p times y, the quantity y minus k, or y minus k quantity squared equals plus or minus 4p times quantity x minus h. You know that an ellipse is x minus h quantity squared divided by a squared plus y minus k quantity squared divided by b squared equals 1. You know that hyperbola is very much like an ellipse, except it's subtraction. Okay? And the x's might come first, the y's might come first. And then I'm just refreshing your memory that a line is y equals mx plus b. Okay? All right? So we got all of those different things that we are going to be intersecting. Okay? So there are three ways to solve quadratic systems. What do you think they are? What do you think the three ways to solve a quadratic system is? What? Graphing's one of them. What's another one? Elimination. What's another one? Substitution. Okay? All right? So it's solved the same way, except now we got those squared terms in there. Okay? So let's deal with substitution today. Okay. Tomorrow we'll deal with elimination. Or actually, no, tomorrow we won't have class. Tomorrow we'll have formative. And then Wednesday we'll deal with elimination. Okay? And then we'll deal with graphing as we're going along. Okay? Because we can check it by graphing or verify it by graphing. Okay? So, substitution has in it 4 different steps. Okay? Step number 1 says we are going to solve one equation for x or for y. Now, in order to do substitution, you gotta have a non-squared variable. For sure you need a non-squared variable, and that would be one that you would solve for. Okay? So, for instance, in this case, I'm going to solve the second equation for y. Okay? And it just happens to be that it is done for me. Then what I'm going to do is I am going to substitute that in. I'm going to take this x minus 1 and I'm going to replace y with it. So this becomes x squared plus, now instead of y, I'm going to put x minus 1 quantity squared equals 13. And now it says that I have got to solve that chunk. Well, I'm going to solve that chunk by taking x minus 1 and squaring it. Now, if you are a proponent of bad math, you would get x squared plus 1 there, right? Because you would just square the x and you would just square the negative 1. Okay, but that's bad math. Because x minus 1 quantity squared, remember, is really x minus 1 times x minus 1, which is x squared minus x plus 1. So that simplifies to be x squared minus 2x plus 1. Since I have a squared term that hasn't gone away yet, I'm going to make this be 2x squared minus 2x minus 12 equals 0 by subtracting 13 from both sides. If I subtract 13 from both sides, I get that. They all have a 2, correct? Yes. 2, 2, and 12 all can be divided by 2. So let's divide everything by 2. That gives me x squared minus x minus 6 equals 0. How can I solve x squared minus x minus 6 equals 0? What are my choices, Daniel? Factor, are there two numbers that multiply together to be negative 6 and add to be negative 1? What are they? What do you got? 2 and 3 multiply together to be positive 6 and add together to be 5.
X plus 2 and x minus. Yeah.
So positive 2 and negative 3? I would go with positive 2 and negative 3. Okay. So that means I got to set those equal to 0, right? 0 product rule. So then I get here x is equal to negative 2 and x is equal to 3. Right? What's up?
Underneath you subtract 13 on each side. How do you get the 2 in front of the 2x squared?
X squared plus x squared. Okay. So now I've got to find the points. I know that x is equal to negative 2, and I know that x is equal to positive 3. Okay? So, how I do that is I first, oops, I went a little too far on that one. There we go, bring it back down. There we go, there's my 2, love it. Okay, so I first look at x equals -2. And what I do is I have to plug that into both of those 2 equations. I can't get away with just plugging it into one. I've got to do it into both. Okay? So if I plug in -2 into that top equation for x, I get -2 quantity squared plus y squared equals 13. What is -2 squared? 4. So this is really 4 plus y squared equals 13. What would you do next? Subtract 4 gives me y squared equals 9. What would you do next? Square root gives me what? No. Y equals plus or minus 3. Right? Okay. So that's telling me then that if x is -2, y is either 3 or -3. Agree? Okay. So those are possible points right there. Okay. Now I got to plug -2 into y equals -2 minus 1. I got to plug it into the second equation also. What's -2 minus 1? -3. So here, that tells me then that this point doesn't work. Because I would have gotten +3 and -3 there if both of them worked. With me? Okay. Now I've got to try x equals 3 again into both equations. Okay. So then now here this is going to be 3 squared plus y squared equals 13, which is 9 plus y squared equals 13. Subtracting 9 from both sides, that gives me y squared equals 4. Square rooting both, that gives me y equals plus or minus 2. So then those would be 3, 2 and 3, -2. Right? Plugging it back into the other one, y equals 3 minus 1 gives me y equals 2. So then this one gets eliminated. And my answers then are just -2, -3, and 3, 2. Now, let's go back and let's do a little bit of logic here now. Oops, I can't quite get them in there. Okay, actually we'll go all the way back to the top. Okay, this one right here. What kind of a conic is it? It's a circle. Talk to me about said circle. Look at her. Okay, but tell me more about the actual circle. yes, those are the 3 reasons why we know it's a circle. But what do I know about that particular circle?
Center point's at 0, 0.
Center point's at the origin.
And radius,
Square radius is square root of 13, so that's what? A little bit more than 3, a little bit less than 4, so about 3.5. Okay, love it. So it looks kind of like that, right? Okay. Talk to me about y equals x minus 1. It's a line. Y-intercept is at
0, 1.
Y-intercept is at
1, 0.
Y-intercept is at Y-intercept is at
-1.
at -1, right? So 0, comma -1, because it's minus 1. Okay, so that means it's down 1 from the origin, right? Okay, what else can you tell me about that line? So what does that mean? Up and which way? Up and right. So it would look something like that, right? Agree? So it would agree that it intersects the circle twice, right? Once in quadrant number 3, which is the negative quadrant, right? And once in quadrant number 1, which is the positive quadrant. Yes? Okay. So, yeah. Because we got a positive and a negative, right? Boom. Shakalaka. Okay. And both of them work out. 2 squared is 4. Or excuse me, -2 squared is 4. -3 squared is 9. 2 plus 9 is 13. Or excuse me, 4 plus 9 is 13. So it checks out on the circle. -3 is equal to -2 minus 1. Checks out on the line. +3 squared is 9. +2 squared is 4. 9 plus 4 is 13, checks out on the circle. 2 is equal to 3 minus 1, okay, which checks out on the line. Okay, love it. What? Yeah, you do that one. Logic tells me, what's the first one? Talk to me a little bit more about it. I agree that it's a parabola, but talk to me about that individual parabola. Yep. No, I lied. What was the right? Because you move the 8 to the other side, the 8x to the other side, and then that becomes positive. Yep. Okay, so it's a right opening parabola. Okay. Second one, what's the second one? X plus 2y equals 8. What's that? That's a line, right? Okay, all right. So logic tells me that if I've got a right opening parabola, how many different ways can a line intersect it? How many different ways can a line intersect a right opening parabola? You can do twice, right? You can do once. Or it can do what? None. Right? Okay. So I'm either looking for 0 points, 1 point, or 2 points. Okay? Can't have 3, can't have 4, or any more than that. Right? Okay. Preferred method, obviously, would be substitution. So I want to solve what for what? First equation for x, first equation for y, second equation for x, second equation for y. Second for x. Okay? So if I solve the second equation for x, I get x equals 8 minus 2y. Agree? Subtract 2y from both sides. Okay? So then I have to put that, 8 minus 2y, in place of x. So I get y squared minus 10y minus 8 times now 8 minus 2y plus 57 equals 0. So that would be y squared minus 10y minus 64 plus 16y plus 57 equals 0. Right?
Yep.
What does that simplify to be? Minus what? 7? Okay. Is it factorable? What does it factor to be? Yes? Okay. I'm going to scroll back up and I'm going to pull down the originals. Okay. So if y equals 1, then I get 1 minus 10 minus 8x plus 57 equals 0. Yes?
Yes.
Which is negative 9 plus 57 is 48 equals 8x. So I get 6 is x. On the other one, I would get x plus 2 equals 8. X equals 6. So my potential out of that one is the point 6, comma 1. Yes? Okay. What was the other one? 7? Negative 7. Negative 7 squared is 49. Negative 7 times negative 10 is positive 70. Minus 8x plus 57 equals 0. So what do we got there? 49 plus 57 is 90, 106, 176. 22? And then check it in the other one too. So x minus 14 would be there, and then that would be 8. And then, so then that would be x equals 22 also in there. So that gives me a potential point of 22 comma negative 7. Yes? Yeah? Yes, sir. Moving it to the other side makes it positive. Yeah. Okay. And if it was a right opening parabola, right? Okay, right? So that means it's going to expand out to the right, which means I'd have to have that vertex be way, way over if it's going to be negative. Yep. Yep. And the vertex is actually at 4, 5 for that one, if you completed the square. Okay? Good? Now, I'm being generous. You have 2 days to do 2 problems. Okay? And you've got a mod right now.